of this exercise says use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. There's also a hint which tells us exactly how to solve this problem. The hint says let x be any positive integer, then it will be of the form 3q plus 1 or 3q plus 2. Now square each of these and show that they can be written in the form 3m or 3m plus 1. So let's follow the approach given in the hint. Let's assume x to be any positive integer. So if we apply Euclid's division lemma to x and the integer 3, then we can say that x will be equal to 3 times some quotient plus some remainder, and the remainder can have only 3 possible values. The remainder can be 0, the remainder can be 1, or it can be 2. So x can have 3 possible forms with respect to 3. It can be 3q, it can be of the form 3q, it can be of the form 3q plus 1, or it can be of the form 3q plus 2. So now let's find the form of x square for each of these forms of x. So first let's start with the first form, which is x equal to 3q. So if x equal to 3q, then x square, so x square will be equal to 9q square, and 9q square I can write this as 3 times 3q square, like this. So this is of the form 3 times m, where m is some integer that we can use to represent this part. So if x is of the form 3q, then x square is of the form 3m. Okay, now let's take the second form of x, which is 3q plus 1. So if x equal to 3q plus 1, then x square will be equal to 3q plus 1 whole square. So let's square this. So this will be equal to, so let's use the identity for a plus b whole square. So this will be, so if a is 3q and b is 1, then a square will be 9q square, and 2ab will be 2 into 3q into 1, so that's 6q, and then we will have 1. Now what I can do is, from the first two terms I can take out a factor of 3 common, so I can take this out. So this will be 3 times 3q square plus 2q, and then there is this remaining part of 1. So now this is of the form 3 times m plus 1, where m is some integer that we can use to represent this part. Okay, so if x is of the form 3q plus 1, then x square is of the form 3m plus 1. Now finally let's take the third form of x, which is 3q plus 2. So if x is 3q plus 2, so let me write it here. So x square will be equal to 3q plus 2 whole square. So let's again use the identity for a plus b whole square. So where a is 3q and b is 2. So in this case it will be a square will be 9q square, and then 2ab will be 2 into 3q into 2. So that's 12q, and then we will have b square, which is 4. Now what I can do is, from the first two terms we can take out a factor of 3 common, and even this 4 here I can write this as 3 plus 1. And why I'm doing this is so that then the terms 9q square, 12q, and the term 3, these will have a common factor of 3. So I can write this as 3 times 3q square from the first term, and then from the second term we will be left with 4q, and then from this 3 we will be left with 1, and then we will have this final 1, right? So now if I look at this closely, this is also of the form 3m plus 1, where m is some integer that we can use to represent this part. So if x is of the form 3q plus 2, then x square is again of the form 3m plus 1. So we see that if x is of the form 3q, then x square is of the form 3m. In other words, if x is a multiple of 3, then x square is also multiple of 3. And on the other hand, if x is of the form 3q plus 1 or 3q plus 2, then x square is of the form 3m plus 1 in both cases. In other words, if x is not a multiple of 3, then x square leaves a remainder of 1 when divided by 3. To learn more about how QMath can help you crack school and board exams, explore QMath Leap.